So, you've probably seen dozens of PLA types, but have you ever tried one that actually rusts? I recently came across Protopasta's iron-filled metal composite PLA and was immediately curious what it could really do. Turns out it opens up some wild possibilities, but also comes with two big trade-offs. In this video I will show you how it prints, what it's really good for, and whether it's worth your time and money. Hi, my name is Niels and you're watching Perspective 3D. Before I show you the strange things this filament can do, you first need to understand what makes iron-filled PLA different from regular PLA. And once you know what's inside it, a lot of its unusual behavior suddenly makes sense. The thing is, most so-called metal PLAs don't contain real metal at all. They just appear shiny to imitate the look. But when you pick up a spool of iron-filled PLA, you notice the difference immediately. It has a matte finish, looks like a slightly darker PLA, and the filament itself feels rough and a little fragile. Protopasta's trick is simple. They mix very fine real iron particles into regular PLA. And that creates a filament that behaves like plastic and metal at the same time. I will show you exactly how that affects the material in the test. But first, let's check what it means for printing this filament. You might be wondering whether your 3D printer can even handle printing something that contains real metal. And the truth is, it can, but only if you pay attention to a few important details. You can actually feel the abrasiveness the moment you touch the filament. It's rough, almost gritty, and the texture becomes a real problem if your printer uses a standard brass nozzle. Because brass is soft, the metal particles grind it away much faster than you would expect. The nozzle opening widens, the extrusion becomes inconsistent, and your print quality drops sharply, sometimes within a few prints. And it doesn't stop at the nozzle. If you print abrasive filaments often, PTFE tubes and AMS feeders can also wear down over time. They won't fail immediately, but friction adds up, and iron-fill definitely doesn't make things easier. And that's why a hardened nozzle is an absolute must for printing iron-filled PLA. It's the minimum requirement to keep your printer safe. Protopasta recommends a 0.6mm nozzle to reduce the stress on it, but the metal particles are fine enough that 0.4mm nozzles still work perfectly in my test, if you already have one installed. With everything set up, I started my first print, and the moment I pulled it off the build plate, I immediately felt the weight difference compared to the same print in regular PLA. And that made me wonder, with the added metal, is it actually stronger, or does the extra weight hide a weakness? To get a clear answer, I ran a tensile test on my new tensile test machine. No guessing, no assumptions, just controlled force to see how the material really behaves. And compared to standard PLA, the result was obvious. Iron-fill is weaker. And the reason is simple. The metal particles don't melt or blend with the PLA. Instead, they interrupt the internal bonding inside the plastic. The PLA can't fuse cleanly around the iron, so the parts end up with tiny weak spots throughout its structure. The print feels dense, premium and stronger at first, but mechanically it doesn't hold up and it's actually weaker. But besides its density, iron has another property that almost feels like magic. It's ferromagnetic. And this might be the most interesting feature of the filament. Iron-fill contains enough real iron that it actually responds to magnets. But you're not limited to print entire parts that are magnetic. With multi-material printers being pretty common these days, you can combine iron-filled areas with regular PLA inside the same model. That means you don't have to pause the print to insert washers or other metal pieces anymore. You can simply print certain areas in iron-fill, while the rest of the part stays regular PLA. Those iron-fill sections act as built-in magnetic contact points inside the model, and the result is a part that looks completely normal from the outside, but has ferromagnetic zones inside that attach cleanly to strong magnets. I can only imagine what creative designs people will come up with using this approach. And speaking of creativity, it's not always about function. Sometimes it's more about the look. Rusting the filament is the part everyone gets excited about, but it doesn't happen by itself. So what's the actual process to turn a plastic print into something that looks like real rusted metal? This is where most people get surprised. Iron-fill can rust, but almost nothing happens if you just leave it outdoors. The iron particles are mostly trapped under the plastic surface, so you have to expose them first. A light sanding or brushing removes a thin layer of PLA and reveals the metal underneath. Once the iron is in contact with air and moisture, oxidation finally becomes possible. But natural rusting still takes ages, so you need something to speed it up. Protopasta recommends peroxide mixed with acid, but that mixture can be risky to handle if you're not familiar with chemicals, so I wouldn't recommend going that route. I used a simple and much safer method. Plain peroxide with regular salt inside a sealed bag. It's slow but effective, and after about a week you get a natural, realistic rust texture on the exposed areas. And if you want an even stronger effect, you can't just repeat the process until you're happy with the result. But before you go and order your first spool of Protopasta Ironfill, there are a few practical things you should really know. First, while I have no complaints about the filament quality itself, I do have to talk about the spool. The cardboard spool is honestly one of the flimsiest I've ever tested. It's extremely light, it feels fragile, and for a filament at this price point, it just doesn't give you that premium feeling Protopasta is aiming for. I understand the environmental angle, but considering the costs of the filament, the presentation falls short. The second issue is the filament tangling, and this has nothing to do with the spool, it's simply the nature of the material. The rough textured surface that makes Ironfill unique also makes it harder for the loops to slide past each other. A single crossover on the spool can stay locked in place, and that can easily stop a print if you are unlucky. This is something Protopasta should definitely work on and that I had experienced multiple times during my tests. And lastly, the price. I paid almost $45 for a 500 gram spool, which is a steep ask for PLA based filament with iron powder mixed in. It's a unique filament and the results are great, but iron powder isn't a rare ingredient, so the premium feels difficult to justify in my opinion. And that's really what dampens my excitement. The material is fun to experiment with, but the high price and the flimsy spool make me wonder why more manufacturers haven't offered their own versions yet. Let me know in the comments if you are thinking about giving this filament a try. Thanks a lot for supporting the channel by watching this video, and if you want to explore more interesting materials, feel free to check out this video next.